So I've worked out the distance from the point to the plane on the board up here. So notice the plane was x plus 2z, so its normal vector is 1, 0, 2. Since there were no y's in the equation, that's 0 copies of y, so the second component of the normal vector is just 0. So again, I labeled my work because I'm working with different vectors at different points. So I first calculated this vector qp, then I calculated this vector p, which was the projection, and unlike when I was projecting onto a line, the length of that projection is the length that I want. So I just want to point out a little bit of strategic laziness. Anytime you do a projection, you're going to get a scalar multiple of a vector. In this case, that scalar worked out to be 7/5, and it was of my normal vector, 1, 0, 2. You'll notice I did not do the scalar multiplication. I could have written this as 7/5, 0, 14/5, but then I'm working with a bunch of fractions. Since all I needed to do was take the magnitude, I said it's going to be easier to just take the absolute value of that scalar and multiply by the magnitude of that vector. So that's a technique that can make the calculations a little bit less tedious, and I ultimately got 7√5/5. Again, I'm just going to leave this up silently so that you can check your own work for a minute before I turn off the video.